In this video, I'll show you how to solve the ALEKS problem called predicting and naming the shape of molecules with a central atom. In order for us to come up with the shape of a molecule, and this problem is asking us also to come up with a bond angle, we always have to start by drawing a Lewis structure for that particular molecule. We cannot, there's no shortcut, there's no way to answer these questions unless we have a Lewis structure that we can look at. I guess there is a shortcut. The shortcut is to use the internet to look up the Lewis structure rather than coming up with it on your own. You can just Google Lewis structure ICl4-. If you're doing this, just make sure you're being really careful. There are a lot of similar molecular formulas, and so sometimes if you type in ICl4-, like one of the possible options that could pop up is ICl4+, which is not correct. So just double check. If you're using the internet, double check and make sure that you're getting a Lewis structure that is accurate. Like, oh, there's that ICl4+. Again, we don't want that. Here's an ICl4-. What I'm going to do is copy this Lewis structure down so that we have it to use as a reference. Now, another reference that you're going to want for this particular ALEKS problem is a table, which you can find in your textbook, or you can find it somewhere on the internet, or probably in your notes. You want to find a table that is going to give you the number of bonds and the number of lone pairs, or it's going to correlate bonds and lone pairs with the shape of a molecule and also the bond angle. So you'll be able to find a table that's going to have things like, if I've got 4 bonds and 4 lone pairs, or excuse me, if I have 4 bonds and 0 lone pairs, that shape is tetrahedral. If I have 4 bonds and 1 lone pair, that shape is trigonal pyramidal, etc. So you're going to want to find a table that has all of this information together. Once you get your Lewis structure from the internet, or you draw it, what you want to do is focus on your central atom and count how many bonds are on that central atom. And this central atom has a total of 4 bonds. In doing this, if we had double bonds or triple bonds, they would still count as 1. So like if this was a triple bond, which is crazy, we would still be counting this as a total of 4 bonds. And then we also want to count our lone pairs. We've got lone pairs, 2 total lone pairs on the iodine. And again, we're only focusing on what's around the central iodine atom. We're not paying any attention to lone pairs that are on the outer atoms. So if you look this up in a table, a molecule that has 4 bonds and 2 lone pairs, you're going to find a shape that is described as square planar, and that's what we want to enter in here. And in your data table, this data table that you're referencing, you're also going to see bond angles. That's also going to be included in this data table. And so you're just going to add, for square planar, that's a 90-degree bond angle. So again, the biggest tips that you have here are to find that Lewis structure, look it up on the internet or draw it, and then find this table that gives you a relationship between the number of bonds in the lone pair and what the shape of the molecule might be.